Okay, we're going to start out by looking at the definition of an absolute value of a real number. The notation that we use, of course, is the vertical bars on either side of the number in question. Okay. The definition is stated as such that the absolute value of A is A if A is greater than 0. So an example of such would be something like the absolute value of 5 equals 5. Okay. All right. If we have the absolute value of a negative number, like say negative 4, if you will, okay, the second part of the definition tells us that if we do have a number less than 0, okay, that the absolute value of it is the opposite of the number. So the opposite of negative 4 is 4. Okay. And of course the absolute value of 0 is 0. Okay. Now, just to illustrate, I mentioned earlier when we were talking about that idea of a magnitude of a number. Okay. What the absolute value also is from a graphical standpoint is if I have my 0 here on the number line and I have 1, 2, 3, 4, 5, okay, that answer to the absolute value is also not only by definition, but it also represents the distance between 0 and 5 on the number line. True? Okay. And if I look at negative 4 over here, okay, that distance from negative 4 to 0 on the number line is what? It's 4. Okay. So the absolute value is not only by definition, okay, the positive of whatever number is in there, if you will, okay, but it also represents the distance from 0 to that number on the number line. And this is actually going to become rather important that we understand the number line definition, if you will, okay, because later on when we deal with some other types of numbers, okay, this number line idea, we're going to revisit that again, okay, and it's going to help us make sense of dealing with absolute value of numbers that are not real, okay, because right now we're dealing with only real numbers, okay, but when we find the absolute value of a not real number, okay, then we're going to revisit this idea of the number line because it's going to come into play again at that point. Okay. Right. A couple of examples here. Another example, a simpler one that we had on the previous page. We know, of course, that that one is simply going to be 7. What if we have something like this where we have an irrational number, minus 5, pi minus 5? Okay. Well, remember, the way we can express this, okay, we could certainly get a decimal for this and then take the absolute value of that decimal, except for the problem is we'd have to round it at some point. And we don't really want to round it, because if we rounded it, then it wouldn't be the exact answer anymore, would it? Okay. So we'd rather leave it like this, in some form of this. But remember what it boils down to is that pi we know is 3 point something, and we know that 5 is 5. Keeping in mind that 3 minus 5 essentially is going to be a negative number, isn't it? Okay. So based on our definition then, okay, the absolute value of this is going to be the opposite of what's in the parentheses here, isn't it? Okay. So just to review, if I had to take the opposite of what's in the parentheses, okay, or in the absolute values I should say, okay, if I had the opposite of this number, okay, that would be negative pi plus 5, wouldn't it? Okay. So we could write that as either negative pi plus 5, that would be one valid answer for this problem, okay, or we could rewrite that as 5 minus pi. And the question is which one of those is right? Okay. Both. Okay. They're the same number, aren't they? Okay. If I did negative pi plus 5, that'd be the same as 5 minus pi, wouldn't it? Okay. So when we have that situation, just want to make sure we recognize that it could be either one of those, but bottom line is recognize it as negative first, and if it is negative, okay, then we would write it as the opposite. Would we have that same issue if we had pi plus 5? No, because what do we know about pi plus 5? Pi plus 5 is it's positive. So wouldn't pi plus 5 just be pi plus 5? Okay. Okay. So the only reason this changes is because this is actually a negative number in here. So we're going to be a little bit careful about that. Okay. All right. Okay. Last thing we're going to look at is just a couple of properties. These properties, once again, are in your book as well. You don't have to write them all down right this moment. But ultimately, if we have A and B being real numbers, okay, it's always true that the absolute value of any real number is greater than or equal to 0. Okay. So if we saw somebody write this on their paper, what could we say right away? No. Okay, that is not true. Okay, we can't have any absolute value be a negative. Okay, so that's not true. We also have a second property is that the absolute value of the opposite of A is the same as the absolute value of A. So if I had a -5 and a 5, both of those would still be 5. Okay. It is true with the last two with multiplication and division. If we have the multiplication of two things in an absolute value, okay, that the result would be the same if we split those up into two separate absolute values. Okay. However, this is not true if I add A plus B. Okay, keeping in mind that A and B could be negatives. Okay. This is a property we might think, well, isn't this true then? If it works for multiplication, does it work for addition too? Okay. No, not always. Okay. So notice this is not on the list of properties. Okay. We can't take an addition in there and separate it because that doesn't work. Okay. If it's a multiplication, we can. If it's a division, we can. But if it's an addition or a subtraction, okay, can't do it. Okay. So make sure you know that this is not a property, because ultimately it's not true for every example. Okay, these other ones are. Okay.